Hi, my name is Geoff Cole. I'm a scientist. I work at the Centre for Brain Science at the University of Essex in the UK. And what I want to do in the next few minutes is to explain to you why trypophobia occurs, or at least why we think it occurs. It's worth saying that science is only just beginning to recognise trypophobia as a phenomenon, and there's only one scientific paper, peer-reviewed article, which has ever been published, and that was published by myself and my colleague Professor Arnold Wilkins, who also works at the centre. But first, I need to give you some relevant background to one particular aspect of the human visual system to make the explanation make sense. If you can take any visual percept, any image, and you can break it down into its fundamental components meaningful to the visual system. So this would be things like brightness, as I've got here, or luminance, wavelength of light, contrasts, edges. These are all the components which the visual system puts together in order to generate a representation of what's out there, generate an image. Okay, and when you do this, when you break down an image into its fundamental units, when you perform a spectral analysis, you discover this. It's a technical thing. We don't need to go into the exact details, but essentially, as spatial frequency comes down, contrast energy goes up. Now, as I say, what this means is a technical thing. The important thing is this, the straight line. It's almost as if the visual world has a particular signature. You analyse any image, any object, and this is what it does. You get this straight line. Okay. However, trypophobic images don't do that. They don't have this straight line. And what I did with my colleague Professor Wilkins, we performed a spectral analysis on the images and found that they did something different. They have a different visual signature. What they do is, represented in this graph here, they have higher contrasts, particularly at mid-range spatial frequencies. And I've put here in brackets other visual patterns known to be aversive to view also have this characteristic, this higher contrasts at different spatial frequencies. It's not just trypophobic images which are difficult to view for some people. There's quite a range of images which for many people, particularly people who suffer from migraines, there are many patterns which are difficult to look at and can induce migraine. Okay, so that's the background. Why does trypophobia occur? Well, the real clue was when one day a trypophobic individual came to visit me in my office, and they said to me that they'd come across an animal which was a little bit difficult to look at, as a bit aversive. And I said, what animal is it? And they told me it was a blue-ringed octopus. Now, I'd not heard of the blue-ringed octopus. I typed this into Google and discovered the blue-ringed octopus is one of the most poisonous animals in the world. So then I typed poisonous animals into Google, and these are the kind of images you get. And the person who'd come to see me, they couldn't look. They couldn't look at the animals. They were too aversive to look at. So it was a bit of a eureka moment, really. I thought to myself, I wonder if poisonous animals is driving this odd effect, driving this trypophobia. So then myself with my colleague Professor Wilkins, we did a spectral analysis. Remember, where you take an image and you break it down into its fundamental parts. We did a spectral analysis on poisonous animals, compared them with controls, and this is what we found. The important thing is this: the visual signature of the poisonous animals is the same as the trypophobic images. They have relatively high contrast at mid-range spatial frequencies. So the poisonous animals have the same or a similar visual characteristic property visual structure, not physical structure, sort of visual structure, as the trypophobic images. They both relate in that way. So what we think is happening is this, in a nutshell. When a trypophobic individual sees a trypophobic stimulus, there's a part of their brain, an old, evolutionary, ancient part of their brain, trying to say to them, be careful, be wary, that image, I think that image is a poisonous animal. It's got the same visual structure, a visual characteristic, a visual signature as a poisonous animal. So be careful, be wary. Of course, the rational part of the brain is trying to say, it's okay, it's just a lotus seed pod, but there is this other part of the brain trying to tell the individual that's a poisonous animal. So that's why we think trypophobia occurs. Thanks for watching.